Okay, we're going to talk about graphing inequalities with two variables, x and y. So there's a couple different steps that we're going to talk about. The first one is, how do I determine whether points satisfy an inequality? What points make an inequality true? So I set up this table, and you guys can slow it down and fill it in as you're going along. I'm going to put in my first point, which is 1 and 6. The equation would be 3 times 1 plus 2 times 6 is less than 12. 3 times 1 is 3, 2 times 6 is 12, is less than 12. 12 plus 3 would be 15. 15 is less than 12, that would be false. So that point would not satisfy this inequality. Next point is 3, 0. So that would be 3 times 3 plus 2 times 0 is less than 12. 9 plus 0 is less than 12. So 9 is less than 12. Yes, that would be true. 2 and 2. 3 times 2 plus 2 times 2 is less than 12. 6 plus 4 is less than 12. And that would be 10 is less than 12. So that one is also true. Last point, 4 and 3. 3 times 4 plus 2 times 3 is less than 12. 3 times 4 is 12, plus 6 is less than 12. That would be 18 is less than 12, which means it is false. Okay, so that's how you would substitute points into the inequality to prove whether or not the inequality is true or false, whether those points are going to satisfy that inequality. All right, moving on to the next part, we are actually going to graph an inequality now. So I chose y equals 2x. I'm sorry, y is greater than 2x. And I just chose 3 points, 3 x values to substitute in to see what we can get for y. So if I took y is greater than 2 times 0, then what is that equal to? That would be equal to 0. Substitute negative 2 times 2, that would be negative 4. 3 times 2 is 6. So these are 3 points. If I made this into an equation just in order to get ordered pairs, then I could switch it back to an inequality. So now I would graph those. So that would be 0, 0. It would be over negative 2, down negative 4. So that would be 1, 2, 3, 4 here. And then it would be over 3 and up 6. Okay, now here's what's important when we're talking about inequalities. There are different types of lines that we are going to talk about, boundary lines. So a boundary line would be if it's less than or greater than, you are going to have a dotted line because that boundary line does not include the points that are on the line because it is greater than. If it was less than or equal to or greater than or equal to, then we would use a solid line because those points would be part of the solution set. So in this case, we have a greater than sign. So the line that we're going to put on our graph is going to be dotted because it does not include those points. So I'm going to go ahead and I'm going to put a dotted line or a slash line through those points. So if this was an equation, we would be done. But since it's in an inequality, that boundary line splits this graph into 2 planes, one on top of the line and one below the line. We need to shade in one of those 2 to determine what points would satisfy that inequality. So what I like to do is do a test. So I'm going to do y is greater than 2x. I'm going to circle that so you can see that. And then I'm doing it again, y is greater than 2x. Now I want you to pick 2 points, one on each side of that line. So I'm going to come over here and I think I'm going to pick 1, 2, I'm going to do 2, 0 for one of them. And for above, for this whole section, I will do 0, 2. Now, whichever one of those 2 points makes that inequality true, that's the side that we're going to shade. So I'm going to take 2 is greater than 2 times 0. 2 is greater than 0. That is a true statement. Let's try this one. 0 is greater than 2 times 2. 0 is greater than 4. That would be a false statement. Therefore, 0, 2, which is here, 0, 1, 2 is this section. So we would shade in this entire section. Every point that falls in that section satisfies that inequality. So when graphing, you need to determine what kind of a line you're putting on the boundary. Is it going to be a dotted line or is it a solid line? Dotted is less than or greater than. Solid is less than or equal to, greater than and equal to. Once you put your line on there, then you have to determine which side of that graph you are going to shade. All the points in here satisfy this inequality. When we check one point on each side of that line, that will determine which side we are going to shade. Okay, let's try another example of shading. All right, now the thing that we have to realize is that we need to make sure this is in y equals mx plus b form. We want to isolate the y by itself because it makes it easier to graph the line and to find ordered pairs that would satisfy it. So in order to do that, I'm going to take my equation and I'm going to add 2x to both sides. And now I'm going to be in y is less than or equal to -4 plus 2x. Okay, now it should be easy for us to find a couple of points that we can graph on a line. Now, I want you to think about this as an equal in order to find the line. Okay, so to find the line, the boundary line, we are going to set that equal. So y equals -4 plus 2x. Let's pick a couple of points. I'm going to say let's make x 0 because it's always the easiest to do. And then let's make x 1. Okay, we only need 2 points to graph a line. So if I say that 0, 2 times 0 is 0, plus -4 is -4. 2 times 1 is 2. 2 plus -4 is -2. So I'm going to come over and I'm going to plot those points. And over 1 and down -2. Okay, now go back and look at the original symbol. My symbol was less than or equal to. Since it's less than or equal to, it's a solid line. So I'm going to draw a solid line through those 2 points. Okay, that means that every point on that line satisfies that inequality. It makes that inequality true. So now we have to decide which side of these two are we going to shade. Which side of the boundary are we going to shade? So I am going to test 2 points. So I think for the above, I'm going to do 0, 0 because that's available. If it's available, use it. And below, I think I'm going to do 1, 2, 3. Let's do 4, 0. All right, so our inequality, y is less than or equal to -4 plus 2x. I'm going to write it again. All right, so let's substitute. 0 is less than or equal to -4 plus 2 times 0. 0 is less than -4. Is 0 ever going to be less than or equal to -4? Nope. Let's try this side. 0 is less than or equal to negative 4 plus 2 times 4. 0 is less than or equal to negative 4 plus 8. 0 is less than or equal to 4. That is true. This is false. Therefore, we got 4, 0 on this side, so we're going to shade in that side of our boundary line. That makes the statement true. All right, you're going to have a word problem, and you're going to have to set it up. So you know you have an X and a Y. Okay, a moving van has an interior height of 7 feet, which is 84 inches. You have 12 inches and 5-inch heights and want to stack boxes as high as possible to make them all fit in. Write an inequality to express this situation. Okay, so we know we cannot go any higher than 84 inches. We have 12 inches and 15 inches in height for boxes. So for X, I'm going to say this is my 12 inch. And for Y, I'm going to say this is my 15 inch. So if I have 12, I'm going to do 12x because that would represent the height of 12 and the number of boxes I can fit, plus 15y because that's going to represent the number of boxes that are 15 inches. Now it cannot be any higher than 84 inches, but can it be equal to 84 inches? Yes. So that would be your inequality that you would set up for that word problem.